Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 6 of the November Daily LeetCode Challenge, and prior to this video I've already uploaded the video for the this day 6 question in the Python programming language, and this particular video will be for explaining the Java solution for the same. Okay, if you want a detailed explanation you can go and check out that video, but here again we'll go through the basics of it and then we will try to see the Java solution. Okay, so I hope you would have already gone through this question before checking this video out. I will give the link for this question in the description as well. Okay, so what is this? So you are basically given a integer array and we have to return a boolean in the output. So they are trying to say is that we have to sort the array, but how the sorting will work? See, for sorting we are basically expected to do some swaps, right? Those swaps can only be done, okay, between adjacent elements, and if the two elements have the same number of set bits. Okay, I hope you are understanding the question, because see, if you want detailed explanation you can check out the previous video. In this video I'm just trying to get you the the whole matter of this question in like just 1 or 2 minutes, right? So what is happening? The array is going to us, right? You will have to sort it. That is the final aim. If you can sort it, you have to return true. If you cannot sort it, you have to return false. But how to do the sorting? For that sorting, basically you're expected to swap. What is swap? Basically you will swap this element with this. That is the basic idea, right? But how that swap will happen? That swap can only happen between two adjacent elements. That is the first condition, and the second condition is that the two elements should have the same number of set bits. Only then you can swap them. So what are these set bits? Basically, in the other video also I've given the explanation for that. That for example, if you talk about 8, the number of, if you see the binary representation of 8, it looks something like this. Okay, there will be some number of zeros, then a 1, okay, and 3 zeros here. Okay, so this is the binary representation of 8. But if you talk about 7, the same thing will look like this. Okay, it will have 7 ones. Yeah, right. Yeah, 7 ones. This is how it will look. So basically, it is 4 plus 2 plus 1 is 7, right? So that is why this is the representation of 7. The idea here is each place will be having a power of its own. Okay, it will be a power of 2, and that particular number will be multiplied with it. Okay, in this case, it is 4 plus 2 plus 1. Okay, that's why it's becoming 7. So I'm not going to in depth of this. You can just do a Google search to understand what is the binary representation of a number, right? Here we'll be using inbuilt functions to get this. So the idea here is the number of ones in this particular binary representation is going to be the number of set bits. Okay, so only if two elements are having the same number of set bits and they're adjacent, only then we can swap them. That is the basic idea. So at last we have to return whether following these conditions you will be able to sort the array or not. That is the basic idea here. Okay, we have also discussed about the first example here. Okay, if you see here, these three elements are having the same number of set bits, which is 1, and these two elements are having the same number of set bits, which is 4. So what will happen? So see, what I'm trying to explain is that whenever the numbers are having the same set bit, okay, and they're adjacent, you'll have to make them as a group, as a segment. Okay, and similarly when they're having the same number of set bits, you have to again make them as a group, as a segment. So what will happen is, see, inside them I can sort the way I want. Okay, the way I want. By, see, for example, if I want this to like this, okay, this can be sorted like this, because remember they're adjacent and they're having the same number, but the set bits, right? So I can sort them the way I want. Okay, for example, after sorting, this will look like this. Similarly, these two elements within them I can sort. Okay, it will look like this after sorting. But the problem comes because, see, this is sorted and this is sorted, but I have to return whether this whole array is sorted or not. So the idea here is, what will happen? Remember, this particular 8, okay, I cannot move it out of these three positions. Okay, I cannot move it out of these three positions because these are not having the same number of set bits. Okay, that is the reason. Okay, remember, they are also talking about the adjacency, but see, adjacency is not important to us as long as the group has same number of set bits. For example, if you talk here, I want the 8 to come to this particular group. Okay, this 8 should come here. Okay, though 8 and 2 are not adjacent, but still I can swap by, for example, see, I can swap first between 8 and 4. Okay, and then between these two. So ultimately 2 will come here. That's how it is possible, and 8 will come there. So the idea here is, within a group, that is, whenever a set of adjacent elements are having the same number of set bit, I can move the way I want each of the elements. But when they are not having the same number of set bits, there is a constraint coming. So what will happen here is, these two things I can sort. Okay, this particular group I can sort, this group I can sort, but what will happen? The intergroup dependencies. So what I can do is, see, if all the elements of this particular group are smaller than all the elements of this particular group, I can say that they are sorted, right? Do you agree with me, right? See, this thing I sorted like this. Okay, this thing I sorted like this. So within the group they are sorted. Okay, intra-group sorting is done. But what about intergroup sorting? So if all the elements of this are smaller than this, do you agree with me that I can call that whole array can be sorted? Yes, that is the basic idea. Now what I'm saying, first, all the elements of this should be smaller than all the elements of this. Okay, let us try to optimize this. What I can say, the max element of this should be smaller than all the elements of this. Do you agree with me? Now again, same thing only, but we are trying to make it a bit optimized. Instead of comparing all the elements of this, you know that is ensuring all the elements should be smaller than this. What I'm doing, I'm saying the max element of this should be smaller than this. Okay, if we try to generalize it, what we can say, for every group that we are present, that is for every segment that we are present in, all the elements in this particular segment, there is, let us just imagine this. Okay, we are here, so all the elements on this particular segment should be greater than the highest element of the previous segment. Do you agree with me? Let me repeat again. All the elements of this particular segment should be greater than the highest element of the previous segment. If that is true, then we can proceed. Okay, that means solution is possible, as simple as that, right? Remember, this is generic rule, so the more the segments we have, they have to apply that everywhere. Okay, so I've already given a lot of tracing, so but yeah, I will expect you to check the other video out, because I've done the lots of tracing there. Okay, for each of the test cases here, I've done the detailed tracing, and I've shown you why it works and why it doesn't work. Okay, especially the third example. Okay, here it's very important. So what will happen here is, if you see here, this particular element has three set bits, but all of them have one set bit. So the idea here is, see, this within this group I can sort them. Okay, within this group I can sort them, but the idea here is, 3 I cannot change, that I cannot swap with any other element, because 3 is having only one set bit. Sorry, it is having two set bits, but all of them are having one set bit. So always 3 will remain in the starting, and this thing I can sort, but still 3 is remaining in the starting, and the answer, the actual expectation is 2 should remain in the starting. That's why it should be a false. The idea here is, in this particular thing, if you consider, all the elements in this element should be greater than the max of the previous segment. But is it happening? 2 is the element here which is not greater than the max element of the previous segment, which is 3. That's why this is not sortable. We have written false here. That is the basic idea. So I've given a detailed explanation of this in the previous video. If you can just go and check it out, that will be really nice. Okay, now coming to the Java part, because this video I made for Java, so I don't want to take much time in giving the details of that. Okay, so coming to the Java solution, what I'm taking, first I'm taking the length of it. Okay, I'm storing as n. Okay, then I will be having three variables here. These will be constant. Okay, and they will be changing for, yeah, they are like basically some of the things which are constant for every segment. Okay, so what I'm going to do, see, first of all, the number of set bits in the current segment. Okay, since I'm going to start now the processing, so first of all, I will take nums of 0. Okay, that is the first element of the given input. What I will take the bit count of it. Okay, I'm using the integer bit count function. Okay, you can check it out basically how it works. But the idea here is, the number of ones in the binary representation that will be given by this particular function. Okay, integer bit count of nums of 0 I'm taking. Okay, that will be my number of set bits in the current segment. Okay, current segment elements. Next, what I'm taking, the max element of the current segment. Okay, I am taking nums of 0 here in this case. Okay, then the max element of the last segment. Since I don't have any last segment when I'm at the nums of 0, for that reason I will take the smallest value in the integer. Right, that is the basic idea. Then I'm starting the for loop. Okay, then I'm starting the for loop. See, basically you can also start with 1. Okay, that is the basic idea. Okay, let me learn this and show you. Yeah, so what will happen is, I'm starting from 1 because 0 is already processed. Okay, the n nums of 0 is already processed, so I'm starting from 1 and going till n minus 1. Right, so what I'm doing here, this is the first thing. Okay, if the nums of I, okay, if the nums of I is smaller than the max element of the last segment. As I mentioned, every element in the current segment should be greater than the max element of the last segment. But if this is not true, that is nums of I smaller than the max element of the last segment, simply return false as it is. Okay, that is the first part. Other part is, first of all, I'm calculating the number of set bits for the nums of I. Okay, I'm storing it as nums of set bits. Okay, this is the first thing. Now I will have a if condition and I have a corresponding else condition. Okay, let us go for the if condition first. What is the if condition? I'm checking whether number of set bits is equal to the number of set bits in the current segment. That is, the current element that I'm exploring is part of the existing segment itself. Okay, number of set bits is equal to number of set bits of the current segment. Okay, current segment elements. What I have to do then? I have to just update the max of the current segment elements. Okay, is equal to max of the previous max, comma nums of I, because we are giving nums of I a chance to become the max of the current segment elements. Okay, that is the basic thing. If that is not, that is, the number of bits in the current element is not matching the number of bits, okay, that we have seen previously. So what you have to do, basically, it is time to start a new segment. Okay, that is, the current segment is ending and I have to start a new segment. So what you have to do, some of the housekeeping stuff is, first of all, max segment of the last, okay, max element of the last segment should be changed. Okay, that will be changed to max element of the current segment. That is first thing. Now, since I have allotted this value to this, I can update this now. So I will update this with nums of I. Okay, max element of the current segment will be nums of I now, right? Now, if number of set bits, okay, in the current segment element will be number of set bits in the that we have explored currently. Okay, this is the one that we got currently, right? So number of set bits in the current segment will be this now. Okay, then remember one thing. See, when I'm at the first element of a segment, so what is happening? This particular is not working properly. Why? See, idea here is, whenever a new segment we are approaching, So the previous segment's max should be compared to the current element, right? But here, if you see, the comparison that happened was not like that. Okay. So what we are doing after updating the max element of the current segment, that is, yeah, max element of the last segment, what I do, I will again redo this comparison. Okay. This particular code as it is, I'm going to write it here again. Why I'm doing this? Because see, this particular value and the value after making this change is not the same. Okay. This value, okay, that I'm comparing, and this value, okay, max element of the last element is not the same, because here I'm assigning some value to it, right? So after that assignment, I'm going to redo this check, right? That's what my I'm trying to do here. Okay. So yeah, if it is not matching, if number is less than the max element of the last segment, you have written false. So here these are the two cases when the false will be written. Okay. If false is not written and the whole loop completes, this whole for loop completes, then I will return true. That is the basic idea. Let me quickly run this and show you. As you can see, it is clearing all the test cases. Okay. So this was the Java solution. I will give this in the comment section. I've already solved the Python version of doing it. So the only thing you have to bother here is how to get the bit counts. That is the first thing. And if you're not aware, you have to take the max. This is how you do it, right? And I hope you are clear with the theory part. Okay. If you are clear with the theory part, this code is not something that is very tough, right? The idea is very simple. Okay. Within the segment, all elements can be sorted, because the way they allowed the swapping to happen, this can only be done within the segment. Okay. So yeah, intra segment is done. Now what about inter segment? When it comes to inter segment, what you have to ensure, you have to ensure that all the elements here should be smaller than all the elements here. As simple as that, right? Very simple. To optimize it, how what we can do, max element of this should be smaller than all the elements of this. That's what we're going to do now. Okay. That is the only idea that we're going to follow now, right? That's why for every element, okay, I am comparing it with the max element of the last segment, right? This is the Python code, but I have already explained this in Java code also. The same thing we are doing. Every num sub I should be compared with max element of the last segment. Otherwise, it will return false if it is not true. So yeah, friend, that was this question. And if you see here, it is basically the length is going to be till 100. So the idea here is, since we are talking about the swaps, and the number is around 100, so obviously you can think of bubble sort also, because bubble sort fits in the scenario. The length that is 100 is also very optimized when you think of bubble sort in this particular range. See, if it is very 10 power 5 and all, then bubble sort is not good for here. Okay. But here it is 100, so yeah, bubble sort can be applied. And the swaps that they're talking about is also a part of the bubble sort algorithm. So maybe you can try and check that out. Okay. Maybe that is something that the interviewer might be expecting for you when they give you this kind of questions. Okay. But anyway, the solution that I have explained is also optimal solution. Bubble sort may have a more time complexity. Okay. But here what we are doing, it will be the best, most optimal solution is this, right? So yeah, friend, that was all for today. If you like my efforts, please do consider subscribing to my channel. It really gives a lot of motivation to continue further. So yeah, friend, that was all for day 6 of the November Daily Leetcode Challenge. See you tomorrow. Thanks a lot.